Hello, good afternoon. So it is Tuesday. We're back at it. We're going to jump right into algebra and pick up where we left off, where we were factoring quadratics with coefficients, leading coefficients of 1. So for example, where we left off, factoring something like this. And what I'm talking about as leading coefficient 1 is to say that out front of the x squared term is a coefficient of 1. And so we saw that we can factor this like this. And what we're really doing is undoing this distribution. So we need these to be equivalent. So we can check if we'd like. And indeed, we did factor correctly. Those are the same. You don't have to do that, right? When the question asks to factor, this is the answer. But if that question asks you to factor and you're not quite positive you got it right, go ahead and check. It's no problem. It's a great strategy. It's a great technique. Checking answers is something that will serve you well in just about every class, but especially in math. And we saw right before we ended on Thursday an example like, say, this one, where we are in the case of having that coefficient not be 1, but we're in the kind of unique case where it's a like term between all the terms, so you can factor out the 2, and then it becomes less influential in terms of actually executing the factoring of the quadratic and being able to pull that 2 out. But let's look at, so just a reminder of what we're doing. We're taking things quadratics, so degree 2 polynomials, and we are factoring them, meaning we're undoing a distribution. We want to go to a situation where we're looking at an unsimplified version, a factored version, the factored form of a quadratic or a polynomial. So right there, that's the answer there. Recall that we're able to do this because we are establishing, we are doing it. We're not claiming like that 2x squared minus 8 is equal to anything. We're being very specific. It needs to be an equivalent expression like this. Those equal signs, we are establishing them as true. If we were to do something wrong, the issue with this situation is that since we are the one writing the equal sign, we might be saying, oh, these are equal, but it could be false if we've made a mistake, because those are in fact not equal. I failed to factor the 2 out of the -8 appropriately. So we do need to check that the equal signs that we're writing here are verified, that we verify it for ourselves that they're true. If we're not quite sure, usually that means executing some operations and trying to get back to where you started. Now let's change it up just a little bit. This is off a worksheet I found on Pinterest, mathdrills.com, if you want to look up more. And it's factoring quadratics with coefficients that are not 1. So here's what we're looking at. And we're trying to factor this out. What you might notice is, what does the distribution of something that looks like this, what does it look like? Well, we have 4 multiplications that happen. We have this one, we have this one, and this one, right? So x times x, x times b, a times x, a times b. So what we've dealt with so far is sort of being able to get away with this one, and therefore these, really easily because it's just a 1. So we don't have to worry about the leading coefficient of our terms. But now we don't have that situation. We have 21x squared minus x minus 2. So now the situation is becoming a little bit more complicated. The reality of what's happening here is that these two are simpler to figure out what influence they have on the possibilities. This one will have the influence of saying, okay, out of those possibilities, which pairs are correct. So for example, we've really, from the first to the 21, we've really two options. It's either going to be something like this, where we're needing to figure out what those are, or something like this, where we have to figure out what these two are. Now look at y, right? What am I actually saying by saying it needs to be one of these two possibilities? What I'm actually saying is that 21 factors in two ways. It factors as 21 times 1, and it factors as 7 times 3. And it has to be one of those two pairs. There are no other factors of it, right? You can try to think of some more. Not divisible by 4, it's not divisible by 5, so it's not divisible by 2, for example. But it is divisible by 3 and 7, those are a factor pair, and by 1 in itself, as all numbers are. So these are the only two options for how these might look. However, there's multiple options again to balance in the blanks that I left, right? So in those two blanks, talking about these two blanks or these two blanks, that's where we're trying to figure out, we need two numbers that are factors of negative 2. All right, we need two numbers that are factors of negative 2. Why? Well, first of all, we're talking about this negative 2, right? They need to multiply to that. Because look at this again. It's the a times b piece that gives us a term without x. So where are those positioned? They're right here. That's a and b, unknown values. So we need coefficients that multiply to negative 2, and then the overall, right, ax plus bx, with these as primary concerns will help us determine whether we're correct. So for example, let's look at this first potential factoring, 21x plus blank times x plus blank. Well, the factors of negative 2 have to be positive 2 and negative 1 or negative 2 and positive 1, right? So we're either going to get negative 2 positive 1 or negative 1, or negative 1. No, sorry. That's not correct. So positive or negative 2 could be in either place. And then it would have to alternate with positive or negative 1. So we have 4 options of pairs for these blanks. And they need to multiply to negative 2. So if we start to look at them, we need to be able to do some estimations or quick guesses in order to eliminate some pairs, for example. So like positive 2, negative 1, I'm looking at putting those in the respective slots. That's going to wind up with a negative 21x and a positive 2x. That's nowhere near negative 1x, right? So I'm having already high skepticism for this potentially, because the 21 is so much bigger than this 1, but these 2's and 1's are really close together. So the multiplication here isn't going to be as close together as negative 1x needs it to be. So I'm skeptical of that one. I'm going to take a look at this 7x and 3x. And leave the sign for a second. So I still am in the situation where plus minus 2, plus minus 1 are my options as factor pairs. So I'm looking at this and I'm thinking, okay, I have a 2 and a 1 to put in here potentially, and I need the difference after I multiply it out to be negative 1. Well, that looks promising here. The reason it looks promising is because 2 times 3 is 6, which is exactly 1 away from 7. So that feels helpful, because that is the gap that I need, and I need it to be negative. So I need the 1 times 7 to be the negative piece, and the 2 times 3 to be the positive piece. Now, don't worry if you're confused and still learning this. Of course, it's difficult. This is definitely one of those times in math where doing it a few times can be really helpful. What are we doing? We're sorting through possibilities to see if any of those possibilities are successful factorings of the initial thing. And so this is the speculation here, and let's just check. Well, 7x times 3x is 21x squared. Okay, not surprised by that. 7x minus 1 is times negative 1 is negative 7x. 2 plus 3x times 3x is plus 6x. And 2 times negative 1 is minus 2. That looks very good. So I'm confident that I found the correct factoring there. Let's do some more. Let me erase a little bit. Now, if you're watching these videos and thinking, yeah, no, I get what's going on, I think you should still concern yourself with doing a little bit of practice on your own, just to make sure that you can do it without needing to follow along somebody else doing it. So it's a good idea to practice on your own here. Let's take a look at another example. Let's do, we're going to factor 7x squared minus 23x plus 6. Now, depending on your teachers, you might have learned a bunch of different kind of techniques for factoring, in the sense of like, how do you come up with the possibilities of numbers and figure this stuff out? That's great. I recommend you look some up and try some out and decide which ones work best for you. For me, in these lessons, I'm just going to focus on how we check our answers. So there's always a chance when you're working you make a small mistake, or you overlook something, and you don't have the correct answer. So I just want to keep reiterating like what exactly we're doing here. We're factoring, we're undoing a distribution, and therefore we can check it by redoing the distribution that we've undone. So when I'm looking at this one, this is maybe even a little easier than the prior one, because 7 in the 7x squared, the 7 only, it's prime. It only has factors 7 and 1. So if this is going to factor, this is an if still, it will have to be factors that look like this. Okay, now, how do we figure out what these other two pieces are? Well, the potential choices for whole number factoring here are factors of the final number here, the coefficient of the 0 power term, so plus 6. What are the factors of 6? 6 and 1, 3 and 2. 6 and 1, 3 and 2. Now, because it's a plus 6, either both of the factors are going to be positive, plus 6 plus 1, or both negative, minus 6 minus 1. It will not be a combo plus 6 minus 1 or something like that. Now, which is it going to be? Well, I suspect it must be both negatives because this term is negative. And so they're going to need to add to a negative number. So it can either be minus 6 minus 1, minus 1 minus 6, or minus 3 minus 2, or minus 2 minus 3. So those are our options. Let's play around with the minus 1 minus 6 for a second. Let's say we think, oh, that's what it is. Now the question here is to check it. So we get 7x squared plus, minus 42x minus x plus 6. Now it shouldn't surprise us when we're all said and done that this isn't necessarily like way off from what the answer is. Obviously this is not right because minus 43x isn't minus 23x, but we shouldn't be surprised that this and this are correct. That's how we decided on these in the first place as possibilities, right? But it's not quite right, so we can always, checking is a great idea because if you're stuck, if you forget like what you're supposed to do in order to analyze them in sort of an estimate way, that's perfectly fine. Do a couple out by hand. You'll start, I think, to get a sense of like what makes sense here. Should it be the 6? Do I need it to multiply by the 7? That would be the biggest possibility, right? Or maybe is it 3s and 2s? And my instinct is it's 3s and 2s, because if the 1 and 6 were reversed here, then we'd be pretty small. We'd be maybe around the 13 range. But if we did some 3s and 2s, we have two options, either a 3 here or a 2 here. Now let's play it out. The 3 here, you get 3 and 14, that's 17. The 3 here, you get 21 and 2, that could be 23. So that looks good. Oops, excuse the mistake. Let's double check for ourselves. And I'm using this check mark to really indicate that these are correct. It is in the checking that we understand that the equal sign we're trying to establish is in fact appropriate. It is true that 7x squared minus 23x plus 6 is in fact equal to 7x minus 2, all in parentheses, times x minus 3 in parentheses. Oops. All right. Let's pick another good one here. Let's do factor this 8x squared plus 26x plus 20. Immediately, like, you can start to hopefully see like what might some of these look like. Well, it could be like 4x minus 5 times 2x minus 4, because I need 4 times 2 to get 8, I need 5 times 4 to get 20. So we're looking at pairs of factors and how they interact with each other to see if we can get the plus 26 in the middle. So right off the bat, I'm looking at either something like this or something like this, because 8 only has 2 pairs of factors, itself and 1, 8 and 1, or 4 and 2. So now I want to look at 20. I'm thinking, what are its factors? Well, 20 and 1, 2 and 10, 4 and 5. So 20 and 1, 2 and 10, or 4 and 5. And this is a tough one, really. In some of them, I get a good instinct of like, which pair should I look at? This is a tougher one. So like, I'm a little bit suspicious maybe that it could be like +5 and +4 over on the right, because those numbers look pretty good. They're going to be in the 20-ish range. I'm also looking at maybe a 2 and a 10, maybe a 4 and a 5 on the other side. I'm worried about multiplying 8 by 4 or 5, though that's too big. It's going to be bigger than 26, and you recognize some patterns here because both of these are positive. That has implications here. So it's looking like, since both are positive, that means both of the coefficients are positive that we're trying to add here. So 4 and 5 are out. How about 1 and 20? I don't think it's going to do it, right? That's going to be 28. What about 2 and 10 looks good? Oops, I've made a mistake. Oops. +10 +2. Okay. So if we were asked to factor, that would be the correct answer. Couple more today. Well, factors of 6, 2 and 3, 6 and 1. Factors of 15, 15 and 1, 3 and 5. Okay, so it's going to look like one of these two options because those are the only factor pairs of 6. No factor pairs of 15. Let's run through a couple in our head here. It doesn't look like -15 and +1 is quite going to work on the left hand, right? Put them in either slot here. Looks like -1 on the 6 or +1 on the 6 would be 6 or -6. But -15 on the x there be 9s or 21s, something like that. Let's try the other ones, 3 and 5 here. Well, it's a maybe 18 and 5. That looks pretty good, actually, now that I'm looking at it. So 3 times 6 is 18. 5 times 1 is 5. So the difference there, right? And I need it to be negative, so I'm looking at this. Let's double check that. Let's do one more. Well, it's either going to be this or this, because there are only two factor pairs of 15, 15 and 1, or 3 and 5. Now, what are factor pairs of 45? And don't hesitate to do this on the side if you ever want to. Factor pairs of 45, I got 45 and 1. And I think there might only be one other one. No, that's not true. 15 and 3, 9 and 5. 45 isn't divisible by 2, because it's not even. It's odd. It is divisible by 5, which is a good one to know when it's ending in 5. So we should look for those pairs. Okay, so I have 3 options to play through in my head here. I'm pretty skeptical of the 45 and 1, because 45 is going to be a problem. In its smallest case, it's going to be right here, and do 45 times 1x, so 45x. But that'll leave a 1 with a 15, that'll be 60x total. It's too big. Over here, it just is way too big, because 45 times 5x, or 45 times 3x, and then the 1 just can't counterbalance it back to 52. So I feel comfortable saying, okay, it's not these ones. Let's play around with 9 and 5. Let's see here. Well, what is 5 times 15? 65? That's not quite going to work either. About 9 times 15 is way too big. About 3 times 15. Well, it's close. It's 45, but then 15 plus times 1, that's 15. That'll be 60x. That's too much. Let's take a look at those in this secondary pair here. I could do plus 9 plus 5. What does that look like? Plus 9, 9 times 3x, 27x. Plus 5, 5 times 5x, 25x. 25 times 27 looks good. So I'm speculating here, and I'm going to ask the question. I think that it is this. Let's verify. Well, 5x times 3x, 15x squared, plus 25x, plus 27x, plus 45. Now, we shouldn't be at all surprised by these two being right. That's how we decided on it's one of these, and it's one of these. And the question is the middle going to add up to the right number? And in this case, yes, it is, that 52. So that's a check. That's true. This is the answer to factoring 15x squared plus 52x plus 45. So definitely do some practice here. Go ahead and look for some worksheets online. Get a notebook out. Do a little practice on paper. It's a great exercise to try out possibilities for factoring and just verify for yourself, like, okay, why are these possibilities, but why aren't they successful? Well, this doesn't come out right. It's going to be a different number right there. So I'll see you on Thursday. We'll do a little bit more. We may start talking about division, but I think we may do some more factoring as it's such an integral part of what we're trying to do. Until then, take care.